Hello. This is a demonstration that shows you how to run some code from the SFC models package in Python. It assumes you've already installed PyCharm, which is the Python development environment. It's a fairly straightforward installation. And first, before you install PyCharm, you need to install a version of Python, which is available at python.org. I've skipped the installation step and I'm going to go straight to showing you how to use the package after installation. The very first thing you need is you need to install the package. What you see here under File Settings, you have Project Interpreter. So Settings, Project Interpreter, and actually you see SFC models. I previously installed it. But if it wasn't installed, you go here, there's this plus button, and this brings up the available packages, and you see SFC models, and so you could just click on that and then install, but it's done already. So it's installed, and so we can use it. One way of using Python is on the console. There's this Python console down here, and one thing you have to do before you can use anything in Python, you have to import it into memory, into your namespace. The import SFC models work. This means it's installed. If you see something that looks like this, let's try importing a package that doesn't exist, foo-foo, you'll get a module not found error. So if you get a module not found error when you try anything import SFC models or similar statements, that means it hasn't been installed for you. And within PyCharm, you once again, it's Settings and then Project Interpreter Plus. The ease of installation is one of the advantages of PyCharm compared to the raw Python. Installation in Python normally isn't that hard, but there can be difficulties with installation of some packages. PyCharm handles those issues for you. Rather than work on the console, what we're going to do here is I'm going to create a new file, Python file. I'll call it Hello World. And in order to start using the object, we need to do an import statement. I'm going to use a quick shorthand. We do from SFC models dot objects, and here's code completion here, import star. That brings in all the names of objects from that are SFC models objects. Experienced Python programmers don't like this because it's not clear exactly what you're importing. You're just importing everything, but because they can create collisions with existing objects. But for like a hello world example, it's good enough. So now that we have the objects brought in, we can do mod equals model. This is the simplest possible creation of a model in SFC models, and we can run it here. We do run hello world. This was pre-installed, but you just can click on the file and do run, and it shows the output, and there's no output because the model's not doing anything. We just created it. This is the main. The main does the work of building a model. So we'll run it again, and we get a warning now. We see warning triggered, there are no equations in the system. Well, this isn't too surprising. We've created a model but inserted nothing into it. So there's no equations, and so the framework doesn't have a lot to do. So to get a better handle what's going on, what we can do is we can do this command, which was imported here, register standard logs. We will put them into the same directory, dot, and then we'll use a little trick to get the file name. This file variable with the underscores around it, that's the current file name. And what this is doing is creating log names based on this file name. And as you see, hello world.py spawned these 3 log files. And here's one of them, log text. And it's just seeing what happened. First, we created the entity on this line, and then you have model main, and then didn't do very much. You have a bunch of zeros, and then finally, there's no equations. So not useful, but that's the simplest possible code. In order to get something slightly bigger, we do let's see, can equals country. So we're going to create a country object. Countries have to live within a model. So it's country, so you pass in mod, which is the variable holding the model, and then we give it a long name, Canada. And then you have the short code name, which is used within for identification purposes. Usually I do uppercase. Could be lowercase, but my convention is uppercase. And we run this again, and there's still no equations in the system. But we can go into log, and now we see entity created. There's a country, ID is 1, adding a country. And actually it creates a currency zone. Canada, it's a new currency appeared, so there's a new currency zone associated with that country. Generally speaking, the currency zone support has just started. It's not really implemented yet. That's going to be model open from Godlin Lavoie's monetary economics. So we're going to go back here, but now we're going to do something that actually generates equations. All the interactions occur within, between sectors, and so we're going to create a household sector. And sectors live within countries, so we pass it in the can. We just say it needs a name. Once again, household. The name is just, purely for descriptive purposes. We give it a code. I usually use HH for household. And then there's a couple parameters associated with the consumption function, alphas. So now we run, and now there's no more warning. So now we've created, we see why, we've created a household. We're adding a sector HH to country CA. Generally, it's using the codes to describe what's going on. And now it's all these variables. So these are variables that have been added to this sector. And you can see here things like this is the pre-tax income, Inc. After-tax income is the income minus tax. And then here's the demand for good. This is the classical consumption function. It's alpha income times the after-tax income plus alpha fin times lag F. Lag F is the previous period's financial assets. So it's generated, and it's actually at this point it's solving the equations. It's doing it fast. The equation gives a nicer formatting. These are the final equations. And you'll see here the final equations of the system. We see all these equations associated with the household sector. It's the only sector, and it's sticking HH in front of it and double underscores. This way, this tells us this distinguishes variables between the different sectors, and they don't the variable names don't crash into each other. We could have another household sector with another alpha fin, but it'll have a different code here. So there'll be 2 different equations within the system equations. And there's no exogenous variables. There was an equation reduction, which I'm not sure did anything in this case because there wasn't much to begin with. And so these are the equations that were generated. And then finally, this is the solution of the system as time series. I say basically everything here, they're all constants. The only thing that's non-zero are those propensity to consume parameters. The only thing that's changing are the time axis. K is the step, and it always goes 0, 1, 2, 3. T is possibly a decorated version. You could have it go up by 0.25 for like quarterly data. You could say t equals k equal 1950 plus k times 0.25 to have quarterly data starting in 1950. And so this is a tab delimited file, and you could drag and drop that into a spreadsheet program. You need to install, there's no built-in plotting tools within Python. You have to install plotting tools to be able to plot these things from within Python, and that generates another chain of dependencies. But for now, just show this, and they can be imported elsewhere. So that's the basics of how you build a model and how you would run it from within PyCharm. Obviously this is quite simple. With only a single sector, not a lot is happening. You have to add more sectors in order to get interactions, but the minimal number of sectors that generates a coherent model is relatively large. You need a household, a business sector, and a government sector, and plus some auxiliary objects. I don't want to go into that level of detail. I just want to show this is, if you see my example code at bondeconomics.com, this is how you would run this code. You would put the more advanced code into this location and then run, or you download or install the example files. Anyways, thanks.